The Dynaroll M15 Torque Tester has secured a unique niche in measuring the torque of precision rotating mechanisms, while addressing the needs of production and research engineers in a wide range of global manufacturing environments. Please take a few minutes to learn more about the capabilities of this remarkable instrument.
Hello, my name is Craig Goff. I'm a Senior Applications and Technologies Engineer here at Providian Machining and Metals, located in Sylmar, California, just north of Los Angeles. The M15 Universal Torque Tester, seen here to the right, was our custom-engineered response to the request from several hard drive computer manufacturers who were looking to precisely characterize the torque behavior of precision bearing assemblies. The M15 is precisely crafted from machined stainless steel and nickel-plated aluminum parts, greatly contributing to its rigidity as well as ESD capability. Inside the base enclosure are the motion control and signal conditioning electronics. Here we have a precision 15 millimeter diameter bearing, oiled. You can see that it's fixtured inside a piece of black plastic with a small pin sticking out. What we do next is fixture this to the machine on a precision center pin, rotate the bearing contact pin forward, and bring over our load cell. We want to position it at the proper radius, which in this case is 6.5 millimeters. And then we're ready to run. When the fixture cap pin finally touches and displaces the load cell tab, the system computer will capture the force data from the load cell output and ties it to the rotational data generated by an internal optical rotary encoder. The encoder resolution of 4,000 pulses per platter rev provides a measurement data point every 0.09 degree. Looking at the graph on the computer monitor, we can see the rotational traverse distance charted horizontally in degrees, while the vertical axis displays torque in grams centimeter with a maximum boundary of 0.1 grams centimeter. Our torque test results are found on the upper right of the display. Results featured are starting torque, average torque, minimum torque, peak torque, maximum peak to peak, and maximum average to peak torque. The simplicity of this operation can be easily repeated for a variety of parts. Consider this electromechanical device that needs to be precision torque tested. Combination of a miniature PCB and a precision bearing assembly. We also have a precision camshaft assembly mounted within a plastic housing. This one has to be torque tested as well and goes into an infusion pump. A larger format thrust bearing is put into a surgical robot and performs a critical wrist rotation operation. Looking at some of the more esoteric applications that we've had for the M15, look at this. This is actually a gas gauge sensor which is used in a fuel tank. The manufacturer needed to characterize the rotation of the swing arm in the fuel tank very carefully, and in so doing discovered that there were 7 failure modes of the item located internally inside here that could be discovered simply through a torque test. Looking at something a bit larger, we have this. Obviously a piece of bicycle running gear, this used for front wheel, rear wheel, and for crank handle bearing cartridges. Our torque tester was specially adapted to take care of this application, much to the delight of the manufacturer. Needless to say, customized hardware and software were required to address this but that is the nature of our M15 applications responses. Now that you've had an opportunity to see how well the M15 Universal Torque Tester responds to a high precision application, consider challenging us with what you have in your research lab or production environment.
For more information about how you can get your own M15 Torque Tester, email us at pmmsales@providianmedical.com. Thank you.